We're going to look at graphing polynomial functions and what end behavior is. Okay, end behavior is the behavior of the graph as x approaches positive infinity and as x approaches negative infinity. So if we look at this example that I have up here, as my x value gets really big, so as I approach positive infinity, my graph is going to continue to go up and up and up. So the end behavior of this graph would be that it approaches positive infinity as x approaches positive infinity. Now, as I approach negative infinity, my end behavior keeps going down, down, and down. So it's basically asking what's happening on the ends of your graph. So for this first one, we would say that as x approaches positive infinity, this arrow means approaches, my function, so f of x, approaches. Well, now as my x approached positive infinity, my graph kept going up and up, so that would be a positive infinity. And then as x approached negative infinity, f of x approaches, and according to my graph, as x goes to the left, my graph goes down, so it would be negative infinity. This would be the description for my end behavior, and we're always going to use that format. So this next graph that I'm going to draw would be a quartic graph, and we want to look at its end behavior. So we would want to know as x approaches positive infinity, what does my function approach? Well, if you think about x getting bigger and bigger and bigger, my graph is going up again. So my function would be approaching positive infinity. Then you have to do the other side. As x approaches negative infinity, f of x approaches. Now as we go to the left, and we get way out here to the left, my graph is going up also. So it would approach positive infinity. Next example, we'll do a cubic shape. And our setup would be as x approaches positive infinity, f of x approaches, and now we have to fill in that blank. So as x goes to the positive side, as we go to the right on x, what happens to my graph? Well, my graph is going downward. So I would put down negative infinity. And then as x approaches negative infinity, f of x approaches. Well, as I go to the left on my x-axis, my graph is going upward, so my graph approaches positive infinity. So that's kind of an idea behind what end behavior is. Now, we don't always have to have the graph in order to determine the end behavior. We can determine end behavior by looking at two things, the degree and the leading coefficient. So if I have a function, f of x equals 6x squared plus 7x minus 20, all I need to focus on is the degree and the leading coefficient. So basically, I'm looking at this very first term. The rest of that, in the terms of infinity, is irrelevant. So I want to start out by putting as x approaches positive infinity, f of x approaches. Well, what I need to do is I need to analyze this. As I approach a really big positive number, what's going to happen to that really big positive number when I square it? Well, it's going to get even bigger, and it's going to be positive. So I'm going to end up with a really big positive number. Then I have to ask myself, what happens next when I take that really big positive number and I multiply it by 6? Well, it's going to get to be even a bigger positive number. So we would be approaching positive infinity. Then I do the second half. As x approaches positive infinity, as x approaches negative infinity, f of x approaches. Now I need to go back here to the 6x squared and do the same type of thinking. If I put a really big negative number in for x and I square it, it's going to turn into an even bigger positive number. Because remember, two negatives make a positive. Well, then if I take that really big positive number and I multiply it by 6, it's going to become an even bigger positive number. So over here, I would end up approaching positive infinity. Okay, here's a couple practice end behavior ones. Describe the end behavior of each. Well, I can even, before I even look at the graph, I can fill out my format. As x approaches positive infinity, f of x approaches, and then I'll fill in that blank. And then as x approaches negative infinity, f of x approaches, and I will fill in that second blank. So now we need to look at the degree in the leading coefficient. Well, now this graph isn't actually in standard form. So my degree in my leading coefficient is actually this middle term. The rest of this is irrelevant when we're trying to do end behavior. So I'm going to take a big positive number and ask myself, what happens when I take that big positive number and I cube it? Well, it's going to become an even bigger positive number. Then I have to ask myself, what happens when I take -6 times this bigger positive number? Well, it's going to become a negative number, a big negative number. So my answer for the first blank would be negative infinity, because when I was all said and done, it turned out to be a negative number here. Then I go through the same process with a negative number. If I have a negative number, what's going to happen when I cube it? Well, it's going to remain negative. It's going to be a bigger number, but it's going to be a negative one. Then I have to ask myself, what happens when I take -6 times that negative number? Well, the two negatives make a positive. So in my final blank, I would put in positive infinity. Next example. My degree is 3. My leading coefficient is a positive 4. So I can start with my format again. As x approaches positive infinity, f of x approaches, and put my blank there. And then as x approaches negative infinity, f of x approaches. So now, got to ask ourselves, what's going to happen if I put a positive number in and I cube it? Well, that will remain positive. Then you have to ask, what happens when I multiply that big positive number by 4? Well, it's going to stay positive. So I would have a positive infinity here. Now we need to do the same thing for the negative infinity. When I put a negative number in here, what's going to happen when I cube it? Well, it will remain negative. It'll be big, but it'll be negative. And then what happens when I multiply that negative number by a positive 4? It's going to be an even bigger negative number. So I would end up putting negative infinity in that bottom blank. Okay, here's two more. See if you can get these end behaviors figured out. So pause the video, see what you come up with, and then check. For the first one, you should have identified your important term as the 7x to the 4th, so we can ignore those last two. And then when you plug in a positive, you would end up getting the positive infinity. And when you have the negative, you would also end up getting a positive infinity. On the second one, our important term was -3x squared. So when you think of the positive infinity here, it gets squared and it stays positive, but then when you multiply it by -3, it becomes negative. So we get negative infinity. And then when we put in a negative infinity here, we square it and it turns into be positive, but then you multiply it by that -3, so it turns out to be negative again. Okay, so you might be wondering, why do we even do end behavior? Well, we can use end behavior to help us make decisions when we're graphing. We'll go ahead and just go through this graphing example, and before you ever even start, you want to identify what its shape is going to be based off of its degree. Now, since our degree for this one is 3, I know it's going to be cubic. And if you remember from previous lessons, when we have cubic, we have some form of a squiggle shape. So that's going to help us decide our table of values and when we have enough points and when we don't have enough points. So we're going to set up a table of values for x and y. I'm going to start off just by letting x be equal to 0. Well, when I plug 0 in here, I'm going to get back a -10. Then I'm going to let x be a 1 and a 2, just to see where that gets me. When I plug 1 in, I'm going to end up with a -9. When I plug that 2 in, I'm going to end up getting back a 2. I'm also going to pick a couple negative values. So I'm going to pick -1 and -2 just to see what happens there. Well, when I plug in -1, I'm going to get -13 back. When I plug in -2, I'm going to get -30 back. I'm not going to go with any more negative numbers because I don't want to get any farther out than -30. I'm going to come back up and do a +3, just to see what happens when I do 3. When I put 3 in, I end up with 35. Well, I'm going to stop there for now. We can always come back and do more for our table of values, but I'm going to go ahead and plot all of these points. Now, after I plot my points, I see that it started to take on the shape of a squiggle, of a cubic function, but before I stop there, I want to check my end behavior. So when I come back here, my 2x cubed, as x approaches positive infinity, I want to decide what should my graph be doing. So when I cube a positive number, it remains positive, and then when I multiply it by 2, it stays positive. So as my x value gets bigger, meaning going to the right, my graph should be going up. And if I look at my graph, it would be going up. Then I want to do the same thing with the negative. If I cube a negative, it remains negative. When I multiply that by 2, it remains negative. So as x goes to the left, my graph should be going down, which based off of my points it is. So once we've decided that it has the right shape, it's cubic, and that the end behavior matches, we can go ahead and connect our points of our graph. And you're going to follow that same process no matter what kind of graph it is. If it's quadratic, if it's cubic, if it's quartic, you're going to end up doing a table of values and then looking at your end behavior and what the shape should be. Okay, now it's your turn. We're just going to start out with describing the end behavior of each of the following. We'll do the graphing actually in class.